Hello everyone, I am Ali and I welcome you all to code with me one question a day. And today's LeetCode problem is binary subarrays with sum. So in this problem, we are given a binary array nums and we have to find all the subarrays whose sum is equal to the integer goal. Okay, so now let's look at the example. As you can see, this is a binary array and we are given a goal is equals to 2. So we have to find all the subarrays whose sum is equal to 2. For example, this subarray is equal to 2. 1 plus 1 is equal to 2. Okay, therefore we add it. And this subarray is also equal to 2. 1 0 1 0. This is also equal to 2. Therefore we add it. And this subarray is also equal to 2. Okay, let's remove this first. This subarray is also equal to 2. Therefore, we add it. Okay. This subarray is also equal to 2. Right? So, as you can see, there are 4 subarrays whose sum is equal to 2. Therefore, we have to return 4 as the answer. Okay. So, now let's look at the approach how we can solve this question. Okay. First approach that comes to mind is the sliding window approach. Okay. Okay, so for that, let's look at the example and let's see how the sliding window will not work. Okay, so we have to modify that and then it will work. Okay. Okay, so here is the algorithm for the sliding window approach. Okay, so here we can see that we will iterate and we will start with the head and we will loop over till the end of the array and we will start summing up. And if the sum is equals to goal, then we will increase the result because we will think that we have got the result. And then after that, if the sum is greater than goal, then what we will do? We will keep subtracting the tail elements and we will increase the tail. Okay, so this is what the sliding window approach will look like. Okay, but it has an anomaly in it. So, okay, so let's look at it, why it is not the good approach. Okay, let's start from the beginning. At the beginning, the head and the tail will be at the beginning. Okay, and the sum will be 1. Okay, then sum is not equal to goal and is not greater than goal also. Okay, so the head will increase up. The head will increase here. Okay, then again, the sum will become 1. Okay, and again nothing will happen and then again the head will move up. The head will move here. Now the sum will become 2. Okay, and again if sum is equals to goal, then result will equal to 1. 0 plus 1 1. Okay, then again the head will move forward. Okay, the head will move forward here and the sum will again be 2. Okay, the sum will not increase and the result will increase by 1. Okay, so the result will become 2. Okay, now as you can see, again it will move forward. The head will again move forward. Head will come here and the sum will become 3. Sum will become 3. But as soon as we reach here, sum is equal to 3. Okay, the sum is greater than goal. So what we will do? We will minus it. Okay, we will sum minus nums minus tail. Okay, so sum minus nums minus tail. Okay, what it will be? 3 minus nums of tail is 1. Okay, it is 2. Okay, so now the sum will become 2 again and the tail will move forward. Tail will come here. Okay, then again we see that sum is greater than goal. No, it is not greater than goal because sum has become 2. Okay, so it will break here and again the head will go outside the range. Okay, now the head will move outside here and the the for loop will end here. Okay. So as you can see here that with this solution, we are simply forgetting this subarray and also this subarray while we were deleting from the tail, and the head just moved outside and we simply forgot to consider these two arrays. This is why our result is coming 2. Okay, so now let's look at the approach how we can solve this problem. Okay, so now let's understand one thing. Okay, so whose sum is at most L? Okay, if we know this, okay, then we have to find the number of subarrays whose sum is n. Okay, we have to find it, and we know that the number of subarrays whose sum is at most n. Okay, so what we have to do? We have to simply subtract it from number of subarrays whose sum is at most n minus 1, right? Right? This means that at most n minus at most n minus 1. What we will, if we subtract this, we will get exact n minus 1. Exact n, sorry. Okay, we will get exact n. That is, if we subtract at most 2 with at most n minus 1, that is 1. Okay, we will get exact 2. Okay, that means that we will get exact number of subarrays whose sum is equal to 2. Okay, we will get the number of subarrays whose sum is exactly equal to 2. Okay, for that what we have to find? We have to find the number of subarrays whose sum is at most 2. Okay, we have to find those subarrays whose sum is at most 2, and we will subtract it with the number of subarrays whose sum is at most 1. Okay, so this is what. So I have made this dragon for you so that you can understand better. Okay, let's start finding the number of subarrays when we use the at most 2. This at most 2 simply means that we are finding all the subarrays whose sum is less than or equal to 2. Okay, so let's see this. This is 10101, our original array. At the starting, the head and tail is at the 0th position. Okay, so this is the only subarray that can be made. Okay, so it is here 1. Okay, so number of subarrays is 1 here. Now the head moves forward. Okay, now the subarray is 1 0. Okay, this is giving less than or equal to 2, so this is good. And 0 is also, okay, 0 is in itself a subarray. Okay, so we take 0 also. Okay, so now the number of subarrays is 2. Now the head moves forward. Okay, so we take 101. The sum is less than or equal to 2. Okay, so we take this. 01 is also, right? And 1 in itself is also a subarray here. Okay, so 3. Okay, just give me 1 minute so that I can explain you this and let you know how this will work. Okay, so again, here head moves forward. Okay, then 1010 is also a valid subarray. 010 is also a valid array, and 10 is also a valid array. Okay, so these are coming from this subarray only. Okay, from this subarray only. Okay, 10 is also a valid subarray, and 0 is also a valid subarray because it has sum less than or equal to 2. Okay, so the number of subarrays is 4 here. Okay, now the head moves forward. As soon as the head moves forward, okay, what will happen? The tail will move forward. Why? Because here the sum becomes 3, right? Here the sum becomes 3. Okay, so therefore the tail moves forward 1 step. Okay, the tail moves forward 1 step. Okay, therefore the subarray will be 0101. As soon as the tail moves here, okay, the tail moves here. Okay, what will happen? The tail moves here. The subarrays will be this. Okay, so all the subarray will be 0101, 101, 0, 1 and 1. Okay, so you can see that there are 4 subarrays. Okay, I have written this. Okay, now let's see here. Okay, so as I already told, the tail comes here. Okay, now the for loop runs and the head moves forward. As soon as the head moves out of bound, it breaks here. Okay, so you can see that total 14 subarrays are there whose sum is at most 2. Okay, 4, 4, 3, 2 and 1. Okay, so there are 14 subarrays. Okay, now let's see. Okay. Now let's see at most 1. Okay, we have to find number of subarrays whose sum is at most 1. Okay, so you can see 1, 0, 1, 0 at the starting, head tail is at the start, at the 0th index. Okay, so there is only one subarray. Head moves forward now. Okay, so we have 1, 0 and 0. Okay, so we have written it. Then again head moves forward. As soon as head moves forward, what will happen? The tail will move ahead, right? Why? Because it becomes 2. And we have to, what we have to? We have to find 1. Okay, we have to find all the subarrays whose sum is less than or equal to 1. Okay, so tail moves forward here. Okay, tail moves forward here. Tail comes here. Tail comes here. Okay, so now 0, 1 is a subarray and 1 is in itself is a subarray. Okay, so now let's move ahead. Head moves forward here again and 0, 1, 0 is a valid subarray, 1, 0 is a valid subarray and 0 is also a valid subarray. In the same way, the head moves forward again and now you can see that the tail will move forward again. Okay, the tail will move forward again. Now the tail will move 2 steps ahead. Why? Because as soon as it reaches 1 step ahead here, you can see that still it is 2. Okay, it is still greater than 1. That's why it will move 2 steps ahead. Okay, it will move here. Okay, the tail will move here and here. The subarray will be 0, 1 and 1. Okay, so now again the head will move forward. Okay, the head will move forward and it will reach out of bound. Okay, so here it will break and now the total number of subarrays whose sum is less than or equal to 1 is 10. As you can see, as you can sum up all this, it will come 10. Okay, now we will subtract these two and we will get 14 minus 10 is equal to 4, which is our answer. Okay, now let's see how this works. As you can see, we are getting this subarray also and this subarray also. Okay, therefore this will get cancelled out. We are subtracting this subarray will cancel out with this. Okay, this subarray will cancel out with this. This subarray with this. In the same way, this array with this and this array with this. This array with this. Okay, you see that these are cancelling out each other. We are subtracting it. Okay, so what we got now? We got this array. Okay, let's change the color. Okay, we got this array, right? We got this array, okay, which is our valid answer. We got this array, okay. This is also get cancelled out, okay. We get this array our answer. We get this array as our answer. So you can see we get 4 arrays, okay, which is our answer. Okay, so this is the approach. We have taken at most approach, okay. We are still using the sliding window, okay. We are still using the sliding window. It's just that we have simply modified it to reach our goal, okay. So we have taken the at most, okay. So in simple words, what we have to do? We have to find at most goal, okay. We have to define a function at most that will find the goal, and we have to also find a function that will find at most goal minus 1, okay. That is at most 2 and at most 2 minus 1, 1, okay. At most 2 and at most 2 minus 1, 1, and we have to simply subtract that, okay. That will be our answer, okay. So this is the approach that we have to do, okay. Okay, and as I already told you that this simple sliding window technique will not work, okay. Why? Because we are leaving behind this thing, okay. We are leaving behind this subarray and this subarray also. We are leaving behind this subarray, which we have to take into consideration, Okay, so now let's simply code it. And okay, one thing I forgot to mention is that how we will find the number of subarrays, because we will not generate all these subarrays. Okay, we have to just simply find the number. Okay, so the formula is head minus tail, okay, plus 1. Okay, this is the formula to get the number of subarrays. For example, here 0, 1 and 2. Okay, it is here. Okay, so the head is at 2 minus tail is at 0 plus 1. Okay, 2 minus 0 is equals to 2, 2 plus 1 is equals to 3. So we get the number 3. Okay, in the same way here, head is at 3, tail is at 1, tail is at 0, and we add 1 to it. 3 minus 1, 3 minus 0 is equals to 3, plus 1 is equals to 4. We get 4. Okay, so this is how we get 4. Okay, so let's code. Okay, let's code it. And we will simply return from here a function at most, and we will pass the array, and we will pass the goal, and we will subtract it with at most, nums, and goal minus 1. Okay, it is what I explained in the video. Now we have to write this at most function. Okay, private int at most. Okay, we will pass the array, nums, and goal. Okay, now first of all we have to define the variables. Okay, int tail is equals to 0, sum is equals to 0, and what else? Okay, our result. Okay, now we will run a for loop for int head is equals to 0. Okay, head is less than nums dot length, add head plus plus. Okay, so we will start calculating the sum. Sum plus is equals to nums of head. Okay, now while sum is greater than goal, okay, we will keep subtracting it from the tail. Okay, but we have to check one thing more. Okay, what is it? It is that tail should be greater than or equal to head. Okay, it should not be like the tail exceeds the head, because it should not happen. Okay, so this is why this tail is greater than or equal to head is used. Okay, what we will do? We will simply subtract the sum. Sum minus is equals to nums of tail. Okay, and we will keep increasing the tail. Okay, so this is done. Okay, and after that, what we will do? We will simply add to the result. What? Result plus is equals to head minus tail plus 1. Okay, as I said that. Okay, this thing calculates the subarrays. Okay, we will simply return the result. Okay, let's check it if everything is fine or not. Okay, everything looks fine. Let's run it. Okay, sorry, I don't know from where it comes. Good. Tail should be less than or equal to head. Let's submit it. Okay, it beats 100%. Okay, so for the Python and C++ code, you can head over to the link in the description. From there, you will find the Python and C++ code. Okay, so if you have any suggestion for me, you can comment down below. And thank you so much. And I will meet you tomorrow with a new question. Okay, thank you so much.